Hello and welcome to another stream on another Wednesday. And in today's session, we are actually going to talk about how to build a BPMN symbol for Camunda 8. And this should also teach you and give you some information on how you actually can collaborate to the ZB project and how, you can implement certain things there, where you can find these, and what kind of your code should look like and what you should consider. And since I'm not an expert on these topics, I brought some guests. And in total, we are 3 people for today's session. On my left side, there is my colleague Josh Wulf, another developer advocate. And on the right side, there's Philipp, who is working as an engineer in the ZB project. Happy to have you here. It's a pleasure. And why don't you both introduce yourself quickly? Maybe Philipp, since you are the guest here, feel free to start off.
Sure. So my name is Philipp. I'm working in the ZB project, so for the ZB team on Camunda. So I'm developing the ZB engine and everything which is related to this. I'm with Camunda for 7 years now. I've also plenty of community projects around Camunda. And today I will try to hack something.
Sounds awesome. Thanks for that introduction. Hey, Josh, why don't you go next?
Hi, my name's Josh Wulf. I'm a developer advocate at Camunda, and I'm also the open source maintainer of the ZB Node client, which is one of the client libraries for Camunda Platform 8.
Cool.
Based in New Zealand, which is in the future. So it's like 8 o'clock at night on Wednesday night here.
Yeah, sounds awesome. I think, Philipp, you are based in in Berlin, right?
Yes, correct.
Yeah, I think you are even in the office. So that's pretty cool.
I am.
Awesome. Having said so and done a little round of introductions, why don't we talk about the most important thing, which is what's your most favorite cold beverage? So this is kind of a pattern. So in every stream of mine, I'm asking this question to the attendees. Usually I got beer there as well, but since it's 10 a.m. in the morning, I didn't want to start drinking that early. But is there something in your mind which you really enjoy as a cold beverage, even though we are not in those summer months again? It's getting cooler, but still, cold beverages are still needed.
100%. I'm looking forward to coming to CamundaCon at the beginning of next month, October. I'll be in Berlin for the first time in nearly 3 years. I'm going to be in the office, and at 10 a.m. in the morning, I'm going to be drinking Krombacher Weissbier, non-alcoholic edition.
Ooh, fancy. Yeah, that sounds good. So, actually, is there any good beer in New Zealand? I haven't been there yet, and I really can't judge.
One thing, because I don't drink alcohol, one thing I love about Europe, especially Norway and also in Berlin, is you can get non-alcoholic beer absolutely everywhere. Here in New Zealand, we might be in the future in some respects, but we're still catching up on that. So that's one thing I love about the office is there's like 3 different types of non-alcoholic beer there.
Yeah, that's true. No, that's pretty cool. Philipp, do you have any preference when it comes to cold beverages?
Usually I'm more into the warm stuff, but if it's cold, then I would choose Guinness, so the Irish beer.
Yeah, I think Niall would be now very, very proud of you having said so. He is having pure joy feeling right at this moment. Cool. And of course, besides of the cold beverages, I do have another very tricky question, and that's all about your favorite BPMN symbol. Is there anything which you personally really like and want to use over and over again?
It's definitely the Termination end event for me. I mean, I'm a huge Arnold Schwarzenegger fan.
That's pretty cool. Philipp, do you have any special event?
For me, it would be a message event, just because it's so flexible. So you can do a lot of stuff with it, and it can interact with the external world. So everything, an event comes in, information goes out. That's right. Messages.
Yeah, sounds pretty good. I'm going here for the compensation, the compensation event. I do like it because it can be very often very useful to a certain degree if you want to compensate something in case there has an error has been happened. I don't use it that often because its necessity is always depending on what you actually try to model. But I know a lot of people who really love this one. Cool. I think these are the most important questions to talk about right in the beginning, to set kind of the mood and the theme of the stream. And next up, why don't we have a look on what the actual termination end event does? Because we are trying to implement this one in the stream with all compiled brain power. More or less, Philipp will be the main brain, and we are just the two retarded ones trying to help.
Additional neurons.
Yeah, additional neurons. That's a better phrase. Agreed. Cool. Talking about what the termination end event does, I have prepared a little thing, which is just a small BPMN diagram in the desktop modeler from Camunda, and I also have the token simulation plugin installed, so I can simply start this plugin, and then we can take a look on how termination does behave in general. So we do have our main process right here, which runs through a bunch of steps, and we do have a parallel gateway right here. So now when starting the process, we can see a token moving through, splitting up, and we have now two tokens, but when we reach actually the end event, the termination end event, we are going to discard all running process instance or running tokens in the current process instance. And I think that's kind of the trick the termination end event does. So in case you want to discard execution of your process instance, this comes in very handy. For demonstration purposes, even though it doesn't really execute, I have modeled this kind of event-based subprocess down here, which also contains the BPMN event or the termination end event. And that's quite a common mistake because there's kind of this mistake that this end event down here, so let me exit the token simulation, this end event down here would then also terminate all the running instances in this process. And of course it can occur that, there's actually the possible that we do have, for instance, a non-interrupting message event, something like this. Then we do some evaluations and we would then say, hey, let's terminate the process. But doing so would only terminate all running instances in the scope of this subprocess. So that's kind of some kind of extra criteria we need to take into account. Have I forgotten?
So that doesn't terminate the whole process, only the sub-process.
Exactly.
Mm-hmm. What about the one outside step 2.1? Does that, given that that's not in a sub-process, will that terminate all sub-processes in this diagram as well?
Ooh, that's a good question. Hey, Philipp. What would be your assumption there? I'm not an expert on the BPMN 2.0 specification in detail. I haven't thought about this edge case though.
Yeah, it's really like you described. So determination is scoped to its actual flow scope. So in this case, so it's everything on the root scope. And if we're reaching then determined end event, we would terminate the whole concurrent path. And if the concurrent path contains a subprocess, then we would terminate the subprocess as well.
Yep. Sounds very reasonable. Cool. So now we've figured out these three cases. Is there? I think, Josh, you have a different one in mind already.
I got another one. I got another edge case. See the message start event there. If we put some service tasks in that sub process, is that a concurrent path to that main path? So will that outer termination event terminate also the sub process, even though they're not connected? The tokens, independently flowed.
That's an interesting question. Can we try this out in token simulation? Let's see if this is working.
So let's see. So your assumption was, let me get it straight again. So you wanted to have another service task in here, right?
Yep.
And then to reach the termination end event. But I'm just missing something right
No,
now. No, okay.
so we're sitting at step 1.2
Mm-hmm.
in the sub process. We got triggered through the message start
Mm-hmm.
event.
Yep.
We also start the other process from the start event, and then we reach step 2.1 and hit the termination event. Does the
Mm-hmm.
sub process also get terminated?
Okay. Yep. So in order to try this out, I think we need to change it from an event-based subprocess to a usual one in token simulation, because I wasn't able to trigger this one before. Can I? No. Let me do so. Hello. Ooh. Let's change this to a subprocess. I think it should. Does it work now? Or should I? No. Oh yeah, I got what you meant. Yeah. Give me a second.
So to answer the question quickly, yes, it should also terminate the event subprocess because everything is in the same scope. So the root scope and also the event subprocess is containing in the root scope, and the termination and event is in the root scope. So it would clean up everything.
So we could try and model something like this, right, in order to test it in token simulation. And I know you might not be able to see it properly. Something like this. So we have step 1, then we go into a subprocess, and our expectation would be that when we reach this kind of termination end event, that we'll also terminate any
Yeah, this
process
one.
instance which is running in here. So maybe let's oops, not a start event. Let's model it like this. When we would test this out, yep. So there you can see that in the subprocess it's also terminated, whereas when we do, say, for instance, something like this. Is this even valid?
Ooh, okay, this is be a good demo.
It's, yeah, getting a bit funky. Let's see how this one is behaving. It's not a very nice BPMN diagram. I'm fully aware of this. But now we would expect the process to keep running, which it does. So now we'll know a bit more about the behavior of the termination event. Is there any other edge case I'm missing right now, or we are missing right now here?
Seems clear to me. Yeah, the roots, the scope, the nesting makes sense. Logical.
Cool. That's awesome. I think having now discovered the functionality of this BPMN, of this, got too many BPMN events in my head right now, of this termination end event, we can now go over to the actual part of, hey, how do we want to implement this now? And of course, the expertise is on my right side, which is Philipp, who knows very well about how to do this, and he also is very well aware about how to navigate through the code base of ZB. So just to let you know what ZB actually is, and to give you some context around it, I'm quickly sharing my screen again. So we do have a repository, the ZB repository, right here on GitHub. It's publicly available. You can contribute, you can raise pull requests, and there's a bunch of documentation also down here. And ZB itself is the powerhouse of Camunda 8, so the process engine provided in Camunda 8. And yeah, it's quite modern and uses a lot of new technologies. So this, for sure, or the implementation Philipp will show you, is for sure something more advanced. But yeah, I think it's good to get this kind of overview for all of you. Awesome. Yeah, is there anything we need to keep in mind or to make sure when we kick things off? Do you have anything specific, Philip, you would like to mention before diving deep into code?
No, I would just start. So I will write coding. I would also try to explain as much as possible, but also makes sense. Since you're just limited on time, I will also just assume that there's some basic knowledge around how CB works in general, that
Yeah,
we've basically on the event streaming and then process the events and producing something. But I will explain in code, so
cool.
should be hopefully good to understand.
Sounds good. So let's dive into your code project. I see you have IntelliJ opened up already, which is awesome. Um, so yeah, let's begin.
Yeah, cool. So I checked out the CB project. So the CB project contains a bunch of different modules, since it's not just the workflow engine, but there are also distributed systems around and other modules split up. But today we want to implement a new event symbol. So we'll look into the engine, which contains really the core workflow engine logic.
Mhm.
So going to the engine, we have different packages, our main classes, and the tests. To start and drive this implementation, I will start with first creating a new test for this, so we can kick things off.
Mhm.
So I'm moving to navigating to the package, which will probably contain our test for a new BPMN element. So we have here a package for the BPMN elements we're implementing. So I will just create here a new test class.
That's awesome. Um, and I think it's already a thing which I wanted to talk about, which is like the test-driven development method you're using right here. Is this common when developing a project like this? Is this a well-used methodology inside of the ZB engineering team actually?
Yes, and especially here, it makes a good sense because we can immediately see what we are doing and if it's working.
Mhm.
So we have immediately feedback about. And before we implementing stuff, we also thinking about what we're actually expecting out of it.
Yeah, yeah, no, that totally makes sense. Yeah, really appreciate it. While you are typing, I'm just continuing elaborating a bit on my experience about test-driven development, um, which is always fun. And I think back then, when I was also a software engineer, we actually use also to a certain degree behavior-driven development, where you have even more elaborate kind of cases or stories you do describe, which you want to then test over and over again, and you have rather those layered test structures, so even product management or some non-technical role can understand what kind of features you want to achieve with this functionality and how you test them. So I'm really a lot or quite a lot into TDD and BDD. Josh, how is it looking at your side? Have you working with tests a lot, or another
Yeah,
opinion?
yeah, no, definitely. I mean, you mentioned stories. They're basically like computer executable user stories, right?
Hmm.
Or specifications. And it lets you know definition of done when it passes the test if you do it right. And I just published a new update to the ZB Node client today. And it's been 4 months since I published the last one. There's like 150 tests in there for it.
Oh well.
If I didn't have those tests, I wouldn't want to touch the code, because you leave it for months, you come back, you change something, did I break as much as I just fixed? So those tests, they're just invaluable.
Hmm. Yeah,
Yeah,
I do
I
agree.
wouldn't want to leave them to the last thing. I think this is a great way to
Yeah,
do it.
yeah, yeah.
Huge
I
fan.
fully agree there, 100%. Awesome.
Okay.
Cool.
So I can also explain quite a few things.
Hmm.
So I started with created a new class for our engine test. We're currently using Unit 4. We will move soon also to Unit 5, but currently staying still with the Unit 4. So we're using a class rule that contains all the test harness we need to interact with our engine. And so this is what we need. And then we're starting with our first test case, which I would say we're just having a simple case to deploy our process, which should be fine for the start. So since we are writing everything here in code, we creating also our process in code using our BPMN model API. So this is part of also here of the CB project, and I see this model about BPMN. It contains a Java representation of BPMN, so you can use this basically for testing and also to reading and modifying models, but here we're using it for the tests. So we're creating a process which contains a start event and an end event, and that should be it. So what we're trying to do is we're using our rule to send a new deployment. The deployment contains the process, and we sending this then writing it to the stream. Then it should be processed by the engine, doing some stuff and producing something when it's processed. And when it's processed, we want to verify that it was successful. So when it's successful, the deployment should be created, or you can also verify that the process created. So that should give us the then we are sure that it was successfully deployed. So we can run our first process.
It's building, taking some time.
So I have a question. This is obviously some kind of internal engine that you can run for the test. Is it running the actual engine code that you're coding, or is it another engine?
No, it's basically using the engine, but in an in-memory style. So don't start everything which is in CV, so no distributed system or stuff like this, but it's really the engine itself. So the stream processor logic to drive a BPMN further.
Is it then
Oh,
actually easy, so the embedded ZB engine, or is it even something different?
Interesting question. So Easy was the project which I worked with Chris, my colleague, on the CB team in the last community, so in the last hack days. We implemented an embedded engine, which basically is the CB engine, but adds some components to run this in memory. So it replaces some layers, which are usually that you're writing to files or you're doing some networking. So we replace this stuff. But in the end, we're having a dependency to the workflow engine, which we use for easy.
Okay.
So in the test, we have kind of something similar, which is then also kind of similar to what you use for the CB process test library.
Understood. Awesome.
I got my money's worth out of the stream already. Everything else after this is a bonus.
Okay, what we saw, the test is successfully, and what we verify currently is that we're sending the deploy, so writing to the deploy command to a stream, and currently we're just having a simple verification that it has an intent. Every record in CV which is written has an intent, which says, okay, if it's a command, it says, okay, what to do, but if it's an event, it says, okay, what has been done. So in this case, we're verifying, okay, that the result of the processing is an event and it has the intent created. So since the deployment was created, that means it was successful. If it would be not, then it would see, okay, that it would be a rejection, and we can also test this. We can also verify the record type, that the record type should be an event. Why is this now possible? Are we already done? Of course, we are not, because we don't have a terminate end event. We just used a normal end event. So that was already what's possible. So now I would say we should make it a terminate end event and see if it's still possible to deploy it.
Sounds good.
So So using the model API, what can I do? So that's currently just a non-end event, so it's the default one. What I can do, I could call it, I can add some message event definition, so to make it a message end event. Also some for signals, for escalation, and so on. For termination, I don't have something, unfortunately. So we need to first extend our model API to write a test. So usually, so this would be our terminate end event. And we're having here also a builder style, which allows us to do it, to set the properties in a nice way. So assuming that I could have looking at the error, so the existing method, and just going from this step, and then we will see how we can extend the current model API to make the termination, to make it terminable. So we now drive to this class, to this builder class in the model API. So in here, we are now in the model module and in the builder to create a model. And so we have already something here for an error. But as we can see here, there's unfortunately nothing for the terminate. So we will first need to write here a new method that you can also have a terminate end event. This might look a bit cryptic because it's using some type aliases here to make the builder API return the correct types. But we can ignore this stuff and just focus on what's important. Looking, okay, what's done for the end event, for the error event, and then we do kind of just the same for the terminate event. So basically we need to here, okay, we're checking for the error. The error first creates an error event definition, and then the event definition is added to the element. So, okay, we need to do something like this. So first, then we need to create the event definition. You can dive here also. What does it do? And you see, okay, the error event definition is created here with a create instance method and passing here the type of the event definition which you want to create. Okay, we can do something like this. So we're creating an instance of the terminate event definition. This is then our terminate event definition, and we can just add these to the existing event definitions. And that's it, we added it, and then we're returning the element itself because it's a builder, so we want to continue on the same element. So after now adding this termination event definition to the end event, then we should now have a termination end event. So we can now use these here in our test case. Okay, we can now say, okay, the end event should be terminated, usually in this style for this builder. Okay, it says we can also make this a bit more prettier by using a lambda. So now it looks like this. So it says, okay, our end event has a name and is enhanced with the terminate. So adding the termination event definition to it. Now we can run the test again and see what's happening. So will it work? No, hopefully not. Okay, so we have a failing test case, which is extracted, which is good. Okay, that you see here, okay, that you deploy. I'm currently expecting that it was successfully, and it's not. So this is there because we are failing here. So to get a bit of understanding what happened in the engine, we can look into the output. And if you look here a bit here, you would see currently nothing. Okay, we need to add another rule to this. There is a helper class which also then print our log.
And by adding this one, we can basically see a little bit more in the output and get information where the problem is coming from. Okay.
Yes, exactly. So basically, when a test fails, it prints the whole log stream, so every record which was written on the stream, which helps us to really understand what the engine does, because the engine executes everything asynchronously. So in the end, we have no idea. If you're not, and also debugging is complicated because everything is happening asynchronously. So that wouldn't help. Okay, still I don't see any output. That's not intended. So maybe something is not correct with now the class rule. So I would just use a normal rule for this. Okay, so fine. Don't need a class rule yet. Usually we're using class rules because we have many test cases also in a class. So we want to reuse the engine to speed up the tests a bit. For now, it's not so important. It's more interesting that we see the actual output.
The tension, waiting for the output to hopefully show up.
Okay, now we have something. That's cool.
Great.
So looking at the output, so it says start something with here. Okay, compacting a log representation so that everything, the output now is compacted because the records are just too many information. So we writing it in a compact way that we can understand. So if you look now here in the log, we see, okay, this is C for it's a command. Then this is a deployment command and it has the intent create. So when we want to deploy something, we're creating it. And then we see a key here, we got a rejection also from the event. And it says with the failure message here, says something like, okay, expected to deploy, but encountered errors. Here, then they say that the event definition of this type is not supported. And the end event must be one of non-error message. So, okay, we see, so currently it's not possible to deploy something like this. So first, what we need to do to even deploy our process, we need to modify our validations. Okay, let's do this. So let's just search where this term comes from. And we see, okay, here there's an end event validator, which is the term what we're looking for. So, and here it has a field which has the supported event definition, which is here checked. So it's going over all the event definitions for the event and check if everything is supported. So supporting now the termination, we're adding this just here to the list. Okay, now it's in. We adjusting also the error message that it reflects the same. So that was the first one, but there was another one here. So also looking for this. Okay, see there's a class event definition validator. So we also go to this. Here we see that it's a validator going over all event definitions. And then for each event definition, it checks if the event definition, so if the type is in the supported event definitions. So currently it's also not. So we will just edit here. Same as before. So now we adjusted it to validators, which gave us the error message. So yeah, maybe we're done. So trying out.
So that's already a good insight that when you add a BPMN symbol, that you first of all need to also make sure to change kind of the validations for actually even deploying the BPMN diagram. Yeah. And the
Yeah,
test passed.
that's our style. So we try to prevent that you can deploy something, but then in the end, if it's deployed, you're not able to execute this, which would result in failures or unexpected behavior. So in order to avoid this, we have these validators, which are kind of strict and checking if everything is valid in this process.
Yeah.
So when we add something new, we need to also extend the validators. Okay, so we were able to deploy a process, which is great. Okay.
Cool. So it's time for another test case, right? Or for a test.
It is. Since we are now able to deploy our model, we also want to do something with it. So to do something would be then that we can create a process instance, and it's doing something. So something easy, that our goal is now to just complete our process instance. We would again building kind of a similar model.
Do we already, so we already feature like a termination end event, right? Or a usual? No, a termination. Okay.
So using what we implemented before. Process. And we want to deploy it. So we adding this model and we deploying it. Just the first step, and then we actually want to do something. So we want to create a new instance. So then we're using a rule which contains basically just the shortcuts to write a command to the engine in a test-friendly way.
Yeah.
So
I really
we want
like
to
that
create
you. Go ahead. I just wanted to say I really like that you always also say given, when, then. There are so many bad tests which doesn't contain these kind of keywords and the structure, especially if they get longer and longer and longer, and it's very hard to derive what the heck they're even doing. And so this gives you kind of a clear idea on first sight, which I really, really appreciate.
Yeah, this is kind of a usual pattern we apply on the tests to make it more readable. So what we do now, so we want to create a new instance of this process, and then we're returning the process instance key of it. So every process instance is uniquely identified by key, which we here return. So now we want to verify that our process instance was completed. So currently it has the start event and the end event. And so if we reach now the end event, it should still complete the process instance. So which is the very basic test we can start with. Now the tricky thing is that we want to verify the process instance, which is executed everything asynchronously and just represented in the log stream. But what we can usually do in the test case, we can access the log stream and can query it a bit. So there are plenty of different records. So we have records for process instances, which contains everything related to executing a process instance from the process instance itself, but also from the containing elements. So this contains also the start event and the end event and the sequence flow in between. But there are also other records we saw previously for the deployment, but there are for jobs, because every service task is also backed by a job, and for incidents, messages, and so on and so on. We're now interested in the process instance records.
It's so fascinating to see how this kind of development differs so much from how you would, as a user, work with, for instance, the Spring Boot client for ZV. Because you really need to be aware that you can't access all this information in this asynchronously or in this synchronous system. It's quite impressive to see all the thoughts which are needed to make this possible. Yeah.
Yeah, that's interesting in this style of writing tests because you always need to keep in mind it's an asynchronous systems. You can't access synchronously. So everything what you can really check is on the log stream. So now we want to read the records. And since we're using the recording exporter, we also need to limit the stream because we need to say, okay, until what event we want to read, and to avoid that we waiting too long.
There's quite a sophisticated infrastructure in the engine for like introspecting its action for these kind of unit tests. Like it's like the external surface area of the thing is already like sophisticated, but there's like a whole world inside it of like interfaces, utilities like recording exporters, and yeah.
No. I do agree. It's quite impressive to see this, yeah. And
okay, so we're usually using SFJ as a verification framework because it gives us a nice error message when something goes wrong. So now we access in the stream, but the records contain too much information. So we need to kind of extract the information which are relevant to us. So we are interested in the element and the actually intent. So intent would give it information what happened for this element. So we're making this a tuple. So first we extracting from the record, we extracting the element type. So then it would be a start event, a sequence flow, end event, and the process itself. But we are also interested in the intent. First, it would give us the information about what happened. So now we want to verify that it contains a certain sequence. And so we want to have an end event. So the end event should be completed. So there we can look into the different intents what we have per process instance. So different element states. First, when an element gets activated, so that's the command. Then it goes over to the activating, which is the start, and then it gets activated. So when it's activated, then it's kind of the process instance stands in there. If it's then a wait state, so something like a service task would then stand here. And then when it gets completed, we're writing a complete command. Then it goes over the transition from completing, and at the end, it's completed. That's also for termination in case then if the event was cancelled. Expecting that the end event gets completed, and afterwards that the process gets also completed. Which basically describe, okay, we want to have the end event, and afterwards the process instance should be completed.
so currently the end event or the termination end event we have created mimics the simple end event at this point. Okay, because then this test should actually also complete, right?
Mm-hmm. That's a good guess.
Let's see. Might be wrong.
Yeah, exactly.
Luckily.
So we are lucky, and it still works. So it behaves like a normal end event, assuming so, because we didn't implement something for termination logic.
Yeah. Yeah.
So now would be a good time to write another test. That the termination logic actually works as we hope.
And now this time we maybe want to add this kind of parallel flow or to test it. Okay.
Yeah, exactly. So we kind of using what your metal in the beginning,
Mhm.
which then would demonstrate, okay, that we can terminate other element instance, which on the
Yep.
same root scope. So that's build a process. So it had a start event, then it had a parallel gateway. Then we want to have something which we can terminate. So that's having here a user task, giving it a name, an ID. Then this can end in a regular end event. We need to move back to our parallel gateway. And we can have a service task, for example, or
This is
an
like
ID.
logo. You know, we had that little turtle,
Slogan.
and you would make it turn and go forward and turn around. Program It's a programming language where you controlled a turtle and it would move around and draw things.
Yeah, kind of. Okay, so on this path we have our service task, then an end event. It should be our terminate. Terminate, and the other one we can also give it a name that we can recognize on the log, which is the non-end. And so in this case, we want to have it in the terminate fashion. That's our model.
And where's the XML for this terminate event? Might have missed that.
It's already there because the BPM model API itself is kind of complete already because
Ah,
we basically forked it from Camunda 7. So in
wow.
Camunda 7, you can execute basically every BPMN, so it supports almost everything.
Right.
So the model itself contains also already the whole logic for parsing the XML. But
Epic.
what's missing is kind of our builder we're using mainly for our own tests.
Yeah. So you don't have to implement this stuff. You're just writing guards to stop some of these symbols from getting into the engine.
Yes, exactly.
Then until you can implement the actual logic of them. Amazing.
And I do remember actually, like Bernd has written this kind of migration tool from C7 to C8 diagrams. So you have, even though you can't deploy it, it will be then in the web modeler, for instance, is shown as an error. You do still have all the BPMN elements from C7 in there, which can be shown already. But in the meantime, while you have implemented the process, I try to capture it in BPMN in my modeler. So I'm going to quickly hover to go over to my screen share to really see whether I've understood it correctly and also help the audience to picture this. So this is the process I understood you have modeled. Is it correct?
Yeah, correct.
Okay, awesome. Then going back to your code, that's for sure more interesting.
No, it's good that you visualize it. We could also have this, so also if a test would fail, so we've seen this previously, and also in the end it prints out the XML. So we could also use then this XML and paste it back to our modeler, and then you could also show this is especially useful because we have in the engine kind of randomized tests, which are interesting that then we generate a random model to ensure that we can execute it. So we can gain more coverage instead of writing everything explicit, but then having some randomness to ensure this.
That's pretty cool. Because of course, creating random models, you need to follow there are certain guidelines to create proper BPMN, which is actually executable. And having a random model being created with, for instance, the first event being the end event, that would have been weird. So even like taking a look into this, how big this testing framework is and how much work is embedded into it, it's pretty impressive.
Yeah, the whole generation of the process is an interesting topic. We spent a bit of time in this. It is not able to generate everything, so we made certain limitations, but it's still
Of
useful. We
course.
find quite a few edge cases which we didn't cover.
Cool.
So this is nice. Okay. So we have the model, we create a process instance. Then since we have here a user task waiting for the non-end event and a service task waiting for the termination end event. So just to make sure that we are both on the same thing before we reaching the terminate end event, because it's a parallel gateway, so we cannot really be sure which path would be executed first. So we are using this stopper to create the instance first, and then we're using here a shortcut to specify also the type to complete the job which is related to our service task B,
Yeah.
which should then lead that our terminate end event is activated, which then hopefully leads that the user task A is then terminated, which you then would like to ensure.
Pretty fancy.
So when the service task basically gets completed, so by completing the job, we are completing the service task. So when completing the service task, what should happen? Well, we expecting that the user task gets then terminated. And after this, then we want to continue. So, but that's not true. So the service task should not directly after a service task, but after our end event. Now, after our end event gets completed, we want to terminate our user task. And now, since there's nothing behind, we want to verify that now our process instance gets completed.
Is it in stage completed in regards to the process instance? Or so not cancelled or something like this. It's dedicated completed. Okay.
Yeah, so the terminate end event terminates all the other concurrent element instance, so the concurrent activities, but the flow scope itself, it doesn't terminate. So the flow scope, it should complete, because if you look at if you have a process like this and you have an embedded sub-process, and after the sub-process and in the sub-process, then you have the terminate end event and some other concurrent flow. When you're reaching the terminate end event, it should cancel all the other things, but on the sub-process should still continue on this.
Yeah.
So the sub-process then should take the outgoing sequence flow and continue.
Yeah,
in the
understood.
stub flow.
Okay, that totally makes sense. Awesome.
So as we described it so before in the beginning with your examples, then explaining that the terminate end event is really always in the scope of the flow scope and cannot escape from this.
And now this test will fail.
Probably.
Yeah. At least I can predict how the test will be doing. That's something. Awesome.
Move to FTP. Yeah, I made a mistake in the model API. I should use move to a node because it's a gateway and the gateway is not an activity.
Cool. And now when we see the actual source where the test fails, we can then actually implement the first logic for this termination end event, right? Awesome.
Yes.
Ooh. Exciting times.
Okay, so it's now failing properly. So we see here it's failing the test on our sequence. So moving down to the actual output, it's a little bigger here. And what it says, thanks to SRJ, which gives us a pretty error message. And it says, okay, in our subsequence, the user task terminated was not found. Okay. So this was what you expected. We expected the end event to be completed and the user task to be terminated and the process to be completed. And we can now check here in our output what happened. So we see, okay, from the start, then we have the outgoing sequence of the start, then our parallel gateway, which here has our service task, our user task. Then our service task get completed. Then we took the sequence flow and the end event, and the end event was completed, and it stopped. So yeah, it ended here. So because our termination logic is not yet implemented, so we have just a regular end event, and we have two concurrent flows, and there's still the other flow is active, so our process instance doesn't get completed. So now to make this possible, we need to change something to modify our logic for our end events.
Process instance, get tokens, terminate.
Something like this. So everything from the element processing, we have different kind of stream processors, is it? So we have here an interface. If you look into the package, so we have different things for everything. So for end events, for intermediate catch events, through events, for the gateways, and everything is a processor. So processor, because we are in stream processing, so we're reading something from the stream, and then a processor means, okay, we're reading something, and then we should produce something. So this is a processor, reading and producing. And everything works like this, and this is the processor for an end event. Here we see, okay, it's an executable end event, which is kind of the same, but we're having an executable representation of the elements to have some shortcuts. So we can have a quick look here into the processor, which may look a bit cryptic, but we have some behaviors which we are injecting, which contains the usual logic we apply to. And in this case, we see, okay, we usually try implementing three different methods, which is on activate, on complete, and on terminate. So the three different lifecycle phases of an element. But for the end event, it's delegating always here to a behavior. Okay, what's the behavior? We have here currently three different behaviors defined. It's for the non, for the error, and the message. Why? Because we're having three different types of end event currently. So non-event, the error event, and the message event, which behaves all kind of different. So, but these share all kind of the same interface, which reflects the similar methods, which allows you to activate something, complete, and terminate. So what we now need to do is we need to write a new behavior to make this possible and to do something else like the others. So, okay, let's do something. So we need to implement an end-event behavior. We have different things. We need to implement methods, and we need to can choose from three. So we choose from the activate, which is definitely required. If we look into the non-behavior, which is the easiest one, of course, you can see, okay, it's also just implementing the onActivate. And what is done here, it's when it gets activated, when we have here a behavior class, which does kind of helper, which transition our element to activated. So following our lifecycle phases, from activated, then we going to completing, because it's non-end event, there's no logic behind, we're just completing it. And then in the end, we complete it, it's going to be completed. And since there's nothing afterwards, the path ends here. And this then also triggering the flow scope, and the flow scope then checks if there are still active element instances or not, and then complete the flow scope if not. So we need kind of do something similar here, but also something more. So yeah, if there are any questions, please. I'm going a bit fast here.
Yeah, feel free to do so. I think I would have copy and pasted the upper section and removed things that are not useful anymore. That's. I think it's quite good to see that there are already some examples out there which are valid for the other end events. That makes it for sure easier. And of course, if someone is looking into this and wants to implement their own BPMN symbols and make them supported and contribute to this, think it's always good to have these kind of examples in mind where you can take a sneak peek at to see how it's done there, because to me it seems like they're always the same pattern applied with the builder we have previously seen with this processor, so on and so forth. Though there's always this kind of similarity, which is good to keep in mind. Yeah.
Yeah, exactly. We have much in common because we implemented already a lot of elements, so they share kind of similar logic. So we can really look into what's already there and apply the same behavior.
Josh, I think someone from our community actually raised a pull request with some kind of event being implemented. Do you remember what it was? What kind of event?
Was it Alexei?
It can be the
Rudolph?
case. He is for sure very active in implementing things for Camunda 8. But I saw your comment somewhere, but I have forgotten all about it.
Yeah.
No.
Yeah, we had quite impressive contributions to CB already. So recent contributions adding for the timer start events, so timer events, adding the cron expressions, which is expressed really nice. And we had also a contribution recently for the inclusive gateway. So for the forking part, which
That was
is
it, yeah.
It's an
nice.
inclusive gateway.
Yeah,
That's
it was one of our Camunda champions.
Yeah, sounds like Alexei. Yeah.
The inclusive was not from him. It was from Silly, a contributor from China.
Oh
Which
yeah.
also
Oh yeah. I totally forgot about him. Yeah, that's true. He's also very active in the CB sphere. Yeah.
Yes.
Oh, pretty awesome.
Okay, so now we kind of had similar behavior, kind of have the same behavior here already, like for the non-event. So we need to bind this in, so it's used. And we can add the actual other stuff.
This is a real functional kind of programming approach here with this right or left thing. What's that called again? It's like a curry. No, it's like
Yeah,
it's called
exactly.
some logic type of logic, right? It's
That's the either type. We try to apply some more functional style in the engine because it helps us to chain the calls. Because when processing on an element, we kind of need to do several things, like applying input mappings and then also creating event subscriptions and so on and so on. So that's a quite chain of what you should do. And then if something of this can fail, so in this case, then we want to create an incident. So to apply this in nice style using a functional, and for this we just adopted the either type, which has a left and a right side. The right side has the successful result, and the left side has the failure in usual cases.
okay. So this goes right and left rather than left and then right.
So now we want to kind of hook into our terminate behavior somehow.
It's a very different style of programming. It's the nested if else's.
Yeah, Java is still evolving. It may improve in future. So now we kind of need to distinguish the kind of end event. So here for the error, it's checked if it's an error. For the others, it has a job worker property if it's backed by a job worker. So now to distinguish, okay, if it's now a terminate end event. Currently, we see here it exposes something, but nothing which helps us here. See, we can go into the ES errors, which is already existing. So looking here in the executable representation of the end event. And so it's currently not containing anything, which helps us. So let's just create something which helps us to distinguish, okay, this is now a termination event and not an error end event. by adding just a simple boolean. It should be enough for now. So taking a look where these things are set. So just looking at the call hierarchy of the setter, which currently exists, and we ending in the end event transformer. So end event transformer, if you check, we are still in the engine, and the transformer basically works on the model, which gives us from the model API, the past one, and then we're doing some additional steps over it, because working directly with the model API in the engine is not the best performance, because it's reading from XML, it's kind of slow, and to get some information, it's a bit more to do. So we kind of have these other classes which helps us and collecting some information. So here currently the transformer. So there are plenty of different transformers for all elements and other stuff you can have in a BPMN. Here in the end event transformer, it's working on end event and doing stuff. For example, here it checks if it's event definition, if it's a message, or if it's a task definition, then it's probably a message end event to through something, through a message. So in our case, it has an event definition. So we can look into the transform event definition method. Here currently is checking. So it gets the event definition. Usually there is just one. Otherwise it would be a complex end event, which is currently not supported. So safe to assume that we have just one event definition. And if it's an error definition, then we're expecting basically the error out of this. So now we can do something different, since now we have a terminate definition. And if this is the case, then, well, we just added a simple setter, so we can set the termination event. We can set it to true. So now we're having this setting in the transformer, we're having here in our executable end event. So now we can use it. Okay, if it's a terminate end event, then we want to apply this behavior. So we could run our test, but since it doesn't implement something different to the non-end event, it would still fail with the same error message.
So we got the boilerplate for implementing the actual functionality. This looks like pretty much everything we got here is the, I don't know, the interface or the API.
Yeah. Yeah, kind of. And in the function which we kind of need, which is in this case the same, like just going through the lifecycle. Since the lifecycle is kind of the same, but we want to do some additional stuff when we completed the end event. So when we completed now the end event, we want to terminate all the other stuff. So let's do this now, because here we see, okay, the test case still failed. Our use task is still active. Too bad.
Active.
So let's
Process instance, get tokens, terminate.
Yeah, we will do something like this. We need a state behavior, so we currently have this. So first, getting a state.
Oh no. There he is again. Phew. You were very quickly gone. Luckily not for too long.
Couldn't do a hack like you just do cancel process instance on the process instance ID?
Sure, we could just write a command to terminate the process instance, which we could do, and which would terminate, but then we don't achieve that it's really terminating the other activities and then continue. So let's, we have already something like this, because there are other cases where we need to terminate child instances of a flow scope, like for an interrupt event.
Mhm.
We kind of use that.
The other thing is this should only terminate things that are in its own scope, right? It should only cancel the process instance if it's in the root scope, not if it's in a sub process.
Yes. So I've already behavior. We need also the state transition behavior. In the state transition behavior, we can say to terminate an element. And we can have something like terminate child instances, which looks like what we want to use.
Mhm.
And it's terminating child, it's getting a context, so checking the implementation. So it says terminate all child instance of the given scope. Okay, so it's expecting that we passing a scope in it. And here it's taking the child instances of the given scope. And then if you can terminate it, then you will terminate the instance by writing a terminate command. So we need to pass in the flow scope. Okay, so we cannot just use our completed scope because this is of our element itself. So we need the flow scope of this. And now we can use our state behavior to get our flow scope. And we can pass the flow scope context in. So afterwards, then we should terminate all our concurrent element instances. Since it checks also if it's terminated, we will not find our end event because it's already gone. So we should hopefully terminate now our user task.
Let's see. This will be. Ooh.
So is a concurrent or parallel flow node in the same scope, that's a child instance of the scope.
Yes, exactly. So we're going from our current end event, going to the flow scope. So if it's a root element, then we're going to the process instance itself and looking to all the child instance. So the child instance of the process instance is every other active element instance. So including
Cool.
also then the concurrent flow. But oh
And
no,
any
it's not failing.
down into any sub processes as well.
Yeah, exactly. But now we actually have a different error message. So now previously it says, okay, our user task is not terminated. And now it changed that our process is not anymore completed. So I guess we made it worse. So looking what happened. So we see our Pal gateway again, that here's our service task, our user task. So our service task and user task, service task get completed. So this is in our test basically the point here. So then it's taking the end event, which is the terminate end event. And now after it's completed, now our user task gets terminated. Awesome. So it did actually what we wanted to do. But now our process gets terminated. So we kind of achieved what we wanted to. So we canceled our concurrent element instance. But now our process is broken. So we don't want to have it terminated, but we want to complete our process. So we need to change something again. So looking back at our processor, so let's maybe just dive deep what is happening. So on the completed, what is checking here? Well, there's a bit of different code. I can skip a few parts of this. But basically, if the element, it checks if the element is get the outgoing sequence flows, and if it has nothing, then it's kind of the end of the execution path. In case of our end event, which is true. So if this is true, then we're checking we're going to our container element, which can implement method, but this can be implemented by multi-instance, so we can ignore this part. So going back to this. So after this is done, and it was without a failure, but because for multi-instance, when you're collecting things, also things can go wrong, and then can be create incidents and bit more complicated stuff. But if everything went fine, then the element transition to completed. And if it's the end, like for the end event, then we would follow this method. And here basically we going to our container, so our flow scope, and invoking a method which is called after execution path completed. And this is implemented by all the container processors. So for the process, for the subprocess, for multi-instance, event loads, and collectivity, for the containers, which can have children. So going to our processor, now checking what's happening here. So it says, okay, if it can be completed, then it's transitioned to completed, which is good. But do we end up here? No, because for the end event, if we go into our behavior, then we first completing the thing, and then afterwards we terminating the child instance. So we completing the end event, but there's still something left, so we don't go to a parent because the parent has still other child instance, so it doesn't need to care about this. So the process will not complete. So then if this is not the case, then something happens here in the terminate. And by applying the terminate event. And if you follow this path, then, and we are on the processor, then you see, okay, it had also a different path, which is here that the unchild terminated, which was here in the log. We saw, okay, that the user task gets terminated, which will then call our parent that it was terminated. So then we will end up here. It's checking different things like, okay, if it was interrupted is for interrupting event subprocesses, which is not the case here. So it will move to the next condition, which checks if it can be terminated. Looking at, okay, what does it mean? So it checks, okay, if there's any active flow scopes, so active element instances in it. So if not, if there's no active element instances, then it will transition to terminated. So then we'll terminate the process. So now we will end up here because we see, okay, now our process get terminated, which we don't want to happen. So we need to do something else.
That's a lot of digging down and finding the right place where to add something. You need to be good at knowing where your code lies and diving deep into it. Wow.
Yeah, because
Glad this has been recorded.
Yeah, otherwise I would be lost the next time I try. I already wanted to say, like, until this part, I somehow would be able to achieve this, but now it's getting tough.
Not in
Yeah,
Kansas anymore.
Just need to keep in mind, okay, we have this different elements. So writing an event for every element, and every element has its own processor. So you just need to find the right processor and then add your logic there. So now we need to get our instance. So getting our flow element instance, scope instance, like this. Now we need to do something else. So instead of terminating, we need to do something because we don't want to terminate. So it's already immediately kind of broken because usually we have the step for determining something and then it gets terminated. So here we completely missed the step of determining, we just completed. Why? Because here we just checking, okay, if you can terminate by if we have any active children anymore. But now we did something which is not expected to be. That's something that an element gets terminated by a different element in the same flow scope. So we need to think about this case here. So let's build up a check. Getting the instance of the flow scope, which so the runtime information which are stored in the database. and checking if it's actually terminating. And only in this case we terminate. And if not, if it is active, like in this case, we are still active, the process, we want to complete our process, because before we're checking if you can terminate. So if you have any other active element instances, which fits also for this case, so we can just complete it.
Mhm.
We want to complete our process.
Yep.
This doesn't work because it produces void. Just fine. Okay, we can just do this. What do we need to return here? Maybe we can just complete this. Maybe we'll try this. It's simple enough. Let's see if something breaks. Okay, so now we added an additional check. So only if the process instance is completing, then we terminate it. If it's still active, we want to complete it. So let's see.
Tension is rising again. Would be great to see it passing. Hey,
Woohoo. So luckily it passes.
congratulations.
So we were able to fix our previous issue, and now instead of terminating the process instance, we completing it.
Awesome. That looks great. I think since we are already live since 1.5 hours, is there anything you think is very important we need to cover in code for the time being? Are there any edge cases which are relevant for now, or should we just like explain this for the future?
No, there's a few edge cases which we didn't cover yet. So we just implemented this case for the process, but it's missing that we're implementing it for the rest of the behavior. So this can also happen in other places, like for the subprocess.
Yeah.
So since the subprocess is a different processor, but also contains similar logic, which also has kind of the same method, which is doing slightly the same thing. So we also need to implement it there.
Okay, yeah, that's understandable. Cool, but
I have a
Then-
question about.
oh yeah,
I have a question about that last part. You know, I was like, okay, I get it. We're implementing it in the termination event, end event class, and then we went into the processor, and I was like, oh, if I need to implement a new event in the engine, I'm going to have to go into these other processes and mess with them. Like I thought everything would be able to be done from inside that one class, and it would be able to reach out and, I don't know, orchestrate the other pieces that it needed. I didn't know that the implementation would be spread across multiple classes like that. Now it's going to be in the processor as well. Could you walk me through what is it about the process that has changed with the terminate end event that wasn't in there before?
Yeah. Now in this case, for the termination, we so from within the flow scope, we terminate something else. So this is kind of not expected, and we didn't cover it yet because we're reaching a point there is no other active element instances now. So the flow scope get be notified, which then need to check, okay, if I have something else or not. So currently, on completion of an element instance, it notifies the parent, and the parent just, okay, assuming, okay, the child was completed, so I'm in the state of completing, so I can just complete myself. Then the other assumption was if a child get terminated, this would usually be triggered from outside or from something like an interrupting event. Then under this assumption that, okay, if the child gets terminated, then currently the code assumes that because I was terminated or by a terminated boundary event. So I didn't cover the case yet that the flow scope itself is not terminating already, it's still active, and we want to just instead completing it.
Mm. Okay, so I remember when we pitched this idea, you were like, it's challenging to implement new BPMN symbols in ZB, and now I can understand why. Because you really need to understand like how the whole thing works to be able to do it. It's not just like I write a new class and plug it in like it's a plugin or something.
Yeah, exactly. There are easier stuff. For example, the contributions for the cron start event, for the cron support, which was kind of easier because it uses just the existing element and just adding a few steps on it. So it doesn't influence other parts. So it was more focused. Or with the inclusive gateway was also kind of similar already to the exclusive one. So it was shared already some of the code base and just implementing a bit more stuff around, but also didn't touch additional logic like going through the flow scopes. But yeah, implementing a BPM element is kind of tricky, and it requires some deep knowledge about the engine.
Yeah, yeah, that's good to know. So next up, like you said, events might be easier. Let's go for the complex gateway. That will be for sure very easy and good to implement. No, thank you so much for these insights and also showing around how to navigate in ZB and elaborating a little bit on the technical foundations it's built on. Um, to me, I really learned a lot and now envision way better how the code inside of ZB is structured, what kind of architectural principle it uses, like the builder, the processes, so on and so forth, and what to consider when writing tests. This was the biggest wow effect, at least for me. Um, is there any general recommendation you would like to give someone who wants to contribute to the project?
Yeah, before you're contributing, so first check if there's an issue. So usually you're having a lot of issues, but for feature request, maybe not. Then check the issue if it contains any information, or if you're looking for something to implement, check for existing feature requests. There are some plenty of it, and anything are quite good to pick because they're not too complex. And then also looking at the contributions guide because it's explaining a bit how we work and also how to set up your IDE, how the code style is configured, so that you don't format code in an unintended way.
Yeah, I think that's a good
Abs
call
versus
out.
spaces.
Yeah, it's quite a long document, and for sure also within the Camunda 8 Slack channel we do have for our community. There are a lot basically a lot of engineers in there. So if you get stuck, that's maybe also a point where you can crave out for help. I think we are always very keen and very helpful if somebody actually wants to contribute and help them along. So that's always kind of the big thing for us.
Yeah,
Awesome.
we always welcome contributions from outside and we try to support them as much as possible. Um, it's always easier if the scope is smaller. So if you can also shrink the feature down to less changes, like for the inclusive gateway, we also said, okay, focusing on the forking part first and not the joining part would decrease the changes by a lot. So we're easier to merge this in the end.
Yeah, I could fully understand this. Cool. Is there anything else you have in your mind? Any one of you who would like to share it now, or be silent forever?
I have a question. This came from a Camunda champion. He says, like, how do I find out if I have a complex timer set up? When is the next scheduled occurrence for that timer to fire? He wants to reach inside the engine somehow through an API, and I'm like, there's no API that does that. And then he's like, but it must be somewhere. So where is that actually calculated, and is it stored? It must be in memory, right? In some kind of table or something, or
Well, actually, it's written on the log stream. Because when a timer is triggered, so I guess it was a recurring timer. So when the timer is triggered, it also calculates already on creating the timer. It calculates the due date, and then it will write the event for the timer we've created, and then the due date already contains the date when the timer should be triggered. This is important that it's directly serialized on the stream, because on a restart or something like this, so the time will always stay the same. So the information is
right?
rare.
Fancy.
So you can actually get it from the
Yes.
exported stream if you're running self-managed.
Yes. And there are some community projects which also helps you to find out and can read this information. For example, Civil Monitor or CB Play, my newest project.
Oh yeah,
What's it called?
CB Play.
I've seen a
CB
post
Play,
from
okay.
Daniel on LinkedIn yesterday, and this looked also so super interesting. Not sure how it looks time wise on your side, and I know you might not even be prepared for this, Philip. But do you have something you would like to share, or you can share about this right now? Even this was not planned at all.
I could, of course, if you really want to.
It looked pretty cool though. But it might be also a topic for an extra stream. Not sure
Yeah.
where we want to go. So let's keep it for the future. Then
It's really easy
let's
to
do
try
that.
it out. It's on the community hub, so you can just download it from here.
yeah. I will check it out again. But it will take now quite long until I will find it in the community hub. Find the right places where to go.
Yeah, it's pretty easy to find. You just go ZB Play in the search. We should definitely do a stream about that.
Awesome. So, Philip, congratulations. You won't get rid of us. So that's kind of the ZB Play project. And right here you can see these things. And that GIF looked pretty cool, yeah. And it actually also uses ZB and the Hazelcast exporter where you can get all the events from the stream. Awesome. Quite cool. Okay. Anything else popping up in your minds? Otherwise, we can call it a day. We can call it a stream. And of course, once again, I want to thank you all for being involved, for contributing, for helping us to deliver this content, especially you, Philip, for volunteering to go live and writing code live on stage, so to say, and being so
Epic.
elaborate about what you are doing and explaining it so well while you are typing. I always struggle with this kind of multitasking, so kudos to you there.
Sure.
Yeah. So appreciate your time investment, and thanks for all the people who watched. Feel free to check out the contribution guide. Feel free to join the Camunda and Slack channels, and hopefully you've learned a lot about the tooling. So thanks for watching, and see you soon. Bye.
Hosting.
Bye.
Ciao.
You're welcome.